Alright class, in this video I'm going to talk about how to simplify radicals. So the first thing I want you guys to look at is the steps here. What we want to do is find the largest perfect square that can go evenly into a number. So I'll show you what that looks like. We are going to need this chart so that you guys can refer to it. Once we've found the largest perfect square, we are going to split up the two radicals. The one radical that you started with will become two radicals like we see here. The first one is going to be your perfect square. So all the numbers that you see in orange, either one of those numbers are going to fit on the left hand side inside of a radical. Then the remainder that you will multiply from will be on the right hand side. So let's take a quick look at what that means. So the square root of 44, there are different ways, different combinations to get 44, and let me show you. Okay, so those are the three different versions of, like, if I were to split up this into two radicals, I would get the same number of 44. So what we are trying to find, this step one says find the largest perfect square. When you're looking at this part of your these different choices, you want to see where you have the largest square root or perfect square. So any of these numbers that are in orange. So in this case, 1, that is not our largest so far, but that is one perfect square. The square root of 44, we don't have that on here as a number. We do have 49 and 36, but not 44. 2 is also not on our list here. Then we have square root of 22, which is not a perfect square. However, this 4 is, and then just to look at the rest of it, the square root of 11, that's not on our list either. So basically what we're trying to do is, okay, we know that 4 is your perfect square that we can use. That means I'm going to place that 4 inside the first radical, because that is my perfect square, just like I showed you here in this color. In the square root of a, that's where your perfect square goes. That's where I put the 4. And then the 11, which is the non-perfect square of this, the combination, will go in this second. So that's basically how we're going to start it off. And then you're going to simplify. So I'm going to simplify this radical right here, which is the square root of 4 is 2. And then bring over the square root of 11. And this will be my final answer if I were to simplify. 2 times the square root of 11. I know that you don't see a times there, but basically there's an imaginary multiplication symbol in between those two symbols. So, just a recap of what we talked about with the exponent rules. We do have another quotient property when it comes to the radicals, but as you can see here, what happens is if you have a fraction inside of a radical, you have to do the exact same thing to the numerator and to the denominator. We saw this in a previous video, so you're kind of seeing a pattern here. So then, for an example here, we have the square root of 15 and the square root of 4. Well, what happens is you split them both up, and then you just have to simplify both of them. So let's take a look at this problem. So here we are, we have the square root of 15. I showed you the two different combinations. You have 1 times 15 and 3 times 5. Unfortunately, none of those examples give me a perfect square. So really the square root of 15 is already simplified. So I'm going to go ahead and write the square root of 15 on my numerator. However, I can simplify 4. Oops, sorry. The square root of 4 is 2. So that would be my simplified radical. Alright, so hopefully throughout this unit you will be able to kind of memorize the perfect squares. You should have some recollection of it from the previous year. Alright, so I just want to show you another 2 examples in order to help you guys fully understand this concept. So now, I have the square root of 72. I'm going to go ahead and think of all the different ways that I can get 72. Alright, so here's an example of all the different types of ways you can get the square root of 70, or sorry, the 72. So now what we're going to figure out is, okay, I'm going to highlight all of the perfect squares so that I can see which one would be my highest. Well, I know that the square root of 4 is a perfect square, so this is 1. 6 is not, 8 is not, 9 is, 12 is not, 18 is not, 24 is not, 36 is, and then 72 is not. So this is how we've determined like all the squares, all the perfect squares that we have in this type of combination here with 72, but we want the highest number, and that is going to be the 36. So this 36 right here is my highest perfect square. Remember that when we are splitting up our radical, we are going to have our perfect square on one and then the non-perfect square on the other. So in this case, we are going to be looking at 2 times 36 as an entire problem. We're going to plug those two numbers into the appropriate radical. So 36 will go in the first one because that's my perfect square, and 2 will go in the second because I can't simplify 2 anymore. Well, I know that the square root of 36 is 6. Then I'm going to bring over the 2. And then that is my answer. If you want to check to make sure that you did it right, if you go to your calculator, move it over here. Oops. I have the square root of 72 is my original number. So if I put the square root of 72 in my calculator, I will get 8.4852, blah, blah, blah. Now, if I put this, my simplified answer here, which would be 6 times the square root of 2, I will get the exact same decimal. That's how you know you did it correct. Okay? Let's do one more problem. This we're dealing with cube roots. So now we have a different set of numbers that we're going to be looking at, which is the salmon color here, or the pink color. We're going to look at the different possibilities to get 512. So you can go ahead and try to find all the different ways to find 512. And then we'll see which one is the highest perfect cube. So here are the different combinations to find 512. And you know, 512 is actually a unique number, and I'm going to show you that in a second. Well, I'm looking for all the numbers that are perfect squares. In this case, I have 8 and 64. Both of them are perfect squares. So what happens when you have a combination of when you have two perfect squares? Well, in reality, 512 is already a perfect cube, which is right here. This is the number, but I want to let you know that sometimes we are so focused on trying to find the different pairs that we already have a perfect cube. So if I were to go to my calculator here, we'll have the square root of, let me move this to the side, the cube root, so I'll go to math, number 4, enter and put 512, I should get 8. So really, the cube root of 512 equals 8. So that's what happens sometimes if you're working and you notice that you have two perfect squares, or two perfect cubes, then you have already a perfect cube or square as your answer. So just so you know that that is a possibility that might happen when you're doing these types of problems. Alright, I'm going to go ahead and do A and B really quickly for you guys so that you can see 2 other examples, and then let me know if you have any questions in class. Alright, so the square root of 112, I'm going to try to find out all the different possibilities that I can get 112. Alright, so here are the different combinations that I can get 112, and now what I'm going to do is highlight my perfect squares here. And then all we have to do is figure out, okay, which of those is my highest? Well, 16 is greater than 4, so this is a combination that I'm going to be looking at. So my first radical is going to hold my perfect square of 16 times the second radical, which is the non-perfect square, which is 7. Simplify the square root of 16, which is 4, times the radical of 7. So my final answer is 4 times the square root of 7. Okay, you can go ahead and check to make sure that those 2 decimals match up. Okay, So then we're going to look at B, which is the cube root. So now we're looking at different types of numbers. We're looking at, again, the salmon color numbers here on my list. So we're going to go ahead and try to figure out all the different ways to get 54. All right, so here's my list. So now all I have to do is determine which of these is my highest perfect cube, because we have the index 3 in our radical. So one is a perfect cube, but might not be the biggest. 2 is not, 3 is not, 6 is not, 27 is, but 54 is not. So I think we know which combination we're going to use, which is 2 times the square root of 2 times 27 will give you 54. So the first radical will hold my perfect cube of 27, and the second one will hold my radical that is not a perfect cube. And you might be asking, okay, how did you know it was 27? Well, if I look here, my chart, I have the square root of 27 right here. So that's already a perfect cube. Okay. So then the cube root of 27 is going to be 3 times the cube root of 2, because I can't really simplify that even more. So my final answer is 3 times the cube root of 2. Okay, so hopefully this video has explained to you how to find perfect cubes and how to simplify radicals. Make sure that you check your answer, put this in your calculator, and see if these two decimal will match. And that's how you know you did it correctly. Let me know if you have any questions, and good luck solving radicals.